Assalamu alaikum, dear students. This is Wajid Ali Shah, and today we are going to discuss the topic electromagnetic waves, which is given on page number 221 in class second year, subject physics. Dear students, first of all, let me tell you what are waves. Waves, electromagnetic waves, are simply waves, is a very important topic which we have been discussing from junior classes. What are waves? Waves are defined as the carriers of energy. Waves carry energy from one place to another place. Like, for example, sound waves, light waves, and there are so many other examples of waves in life. Types of the waves. There are basically the two types of the waves. One is mechanical wave, electromagnetic waves. And third one, which we'll be explaining in next chapters, like de Broglie waves, are matter waves. Mechanical waves are those waves which require a material medium for their propagation, like sound waves. They are further classified as transverse mechanical waves and longitudinal mechanical waves. Electromagnetic waves are those waves which do not require a material medium for their propagation. For example, light waves. Electromagnetic waves are only having transverse waveform in nature. What are electromagnetic waves? These waves do not need any material medium for their propagation. For example, light waves, radio waves, X-rays, gamma rays, etc. Composition. Electromagnetic waves actually consisting of oscillating electric field and magnetic fields. Electric field reproduces magnetic field, and that magnetic field reproduces electric field. So, oscillating electric field and magnetic field reproduce each other according to Maxwell's equations. Electromagnetic spectrum. What is a spectrum? Spectrum is basically defined as the orderly arrangement of the wavelengths, energies, or frequencies is called spectrum. So electromagnetic spectrum may be defined as, it is defined as the orderly arrangement of the electromagnetic waves based on their wavelengths or their frequencies or their energies, etc. This equation is called wave equation. V is equal to F lambda. This equation has already been discussed in metric class. Again, we can have a brief idea of the equation. V is equal to F lambda, where V is used for speed, F is used for frequency, and lambda is used for wavelength. From this equation, we can find the value of the lambda, like lambda is equal to V divided by F. Wavelength is equal to speed divided by frequency. For electromagnetic waves, as we know that the speed of the electromagnetic waves is equal to the speed of light, that is denoted by c, so c is equal to v. So we can write the wavelength of the electromagnetic waves like lambda is equal to c divided by f. For example, we have a horizontal or a vertical line. You may take any one of them. In this, the central region is visible light, the light which we can see with our own naked eyes, like the light from the sun, light from the tube light, light from the candle, light from the bulb, etc. This is what we call visible light. Visible light is basically consisting of 7 colors: red, orange, yellow, green, blue, indigo, violet. This is visible part of the electromagnetic spectrum. This part is called infrared, and that other side is ultraviolet. Infrared is that energy or color or that electromagnetic waves which is having energy less than red color, so that is named as infrared. Ultraviolet means the having energy greater than violet color, so ultraviolet, greater energy. So if we can represent the waves with the help of sinusoidal equation waveform, so we can see that the wavelength of the wave starting from here and up to here, wavelength is greater, so that's why it gives us less frequency, because we know that frequency and wavelength are inversely proportional, so greater wavelength gives us less frequency. Wavelength is enlarged, frequency is less, and vice versa. And lesser frequency represents lesser energy. So as we move on to the right side towards the visible light and further to the ultraviolet region, so we know that the wavelength has been decreased, frequency increases, and energy increases accordingly. So greater wavelength gives us less frequency. Less frequency gives us the concept of less energy. So we have different forms of the electromagnetic waves, energy levels, different frequencies, different uh, frequencies and energies and wavelength. So we have a list of the electromagnetic waves given in the book as well. The first one, it is the visible light part of the electromagnetic spectrum. The visible part of the electromagnetic spectrum. This the visible region of the spectrum most familiar to us is the electromagnetic radiation emitted by the sun. Sunlight, for example. The wavelength of the visible region ranges from about 400 nanometer to about 700 nanometer breadth. The wavelength of the violet color is 400 nanometer and the wavelength of the red color is 700 nanometer. So the visible part of the electromagnetic wave is having the wavelengths ranging from 400 nanometer to the 700 nanometer. The light is often emitted when the outer or the valence electrons in atom change their state of the motion. For this reason, such transition in the state of the electrons are called optical transition. The study of light emitted from the sun and from the distant stars gives information about their composition. Next one is infrared radiation or infrared waves. Infrared radiation, which has wavelength stronger than the visible light, that is 0.7 micrometer or about 1 millimeter, is commonly emitted by the atoms or the molecules when they change their potential or vibration motion. Infrared radiation is an important means of the transfer of, and is sometimes called the heat radiations. They are used in microwave ovens for different purposes, heating purposes. Next part is microwave. Microwaves are the waves which are having the wavelength range from 1 millimeter to 1 meter. That is microwaves. Okay. Microwaves can be regarded as short radio waves with a typical wavelength in this range, 1 millimeter to 1 meter. They are commonly produced by the electromagnetic oscillation in the electric circuit. As is in the case of the microwave oven. Microwaves are often used to transmit transit telephone conversations. Okay. The next part is radio waves. They are used for TV, radio, and mobile phones. Radio waves have wavelength longer than 1 meter. They are produced from the terrestrial sources through electrons oscillating in wires of the electromagnetic circuit. By carefully choosing the geometry of these circuits, as in the antenna of the TV or a mobile phone, we can control the distribution of the space of the emitted radiation. If the antenna across a transmitter or the sensitivity of the detector, like for example TV signal, radio signal, and mobile phone signals. Next part of the spectrum is ultraviolet radiations. The ultraviolet radiations of the wavelength shorter than the visible uh, begin with the ultraviolet 1 nanometer to 400 nanometer, which can produce in atomic transitions of the outer electron, as well as in the radiation from the thermal sources such as the sun. Because our atmosphere absorbs energy strongly at ultraviolet wavelengths. Ultraviolet lamp is an application, that is what we call UV light. A lamp producing ultraviolet radiation is emitted through clear, filtered particle-free water. This ultraviolet light is extremely effective in killing and eliminating bacteria, yeasts, viruses, molds, and other harmful organisms known to man. Next part is X-rays. X-rays, typically the wavelength are starting from 0.01 nanometer to 10 nanometer, can be produced with discrete wavelength in the individual transition among the inner, most tightly bound electrons of the atom. X-rays can easily penetrate soft tissues but are stopped by the bone and other solid matter. For this reason, they have found wide use in medical diagnosis. Next part is gamma rays. Gamma rays are electromagnetic radiations with the wavelength less than 10 picometer. They are most of the time used for killing the cancerous uh, part of the body, or simply cancer therapy. They are most penetrating of the electromagnetic radiation, most energetic and most penetrating radiations. An exposure or intense gamma radiation can have a harmful effect on the body. These radiations can be emitted in transitions of an atomic nucleus from one state to another, and can also occur in the decays of certain elementary particles. For example, a neutral pion can decay into two gamma rays. Thank you. Have a nice day.